Hello everyone and welcome back to my channel Learn Computing with Daniel Bullen. With me, Daniel Bullen. This time I'm going to go over the 2023 past paper, paper 1, for the OCR GCSE Computer Science spec. Yep, so that's what I'm going to go over. So if you haven't seen it yet, it's also worth checking out paper 2, the controversial paper which lots of people found difficult. Compared to this one, which we'll get through in a moment. So before I do, please remember to click that like and subscribe button and share this video far and wide. Drop a comment down below, and and thank you very much because I enjoy making these videos for you. Let's get right into it. So I'm not going to get into these. I'm not getting into the la-di-da. We know the marks are out of 80. You can't use a calculator. Don't know why, but hey. Okay, first question. Computers represent data in binary form. So we're going to tick one box to identify the statement about binary that is true. The way I do it is process of elimination. So, hexadecimal is 7. If you think about it, we got 8, 4, 2, 1. 4 plus 2? Oh, sorry, not that one. Okay. Binary digits can be only values 0, 1, and 2. Nope. Smallest whole number that can be stored in 8 bits is 1. Yes, that can be true, but that's not what we're looking for. Leftmost of the binary integer is the smallest value? Nope. So what are we left with? Binary is used because computers are made of switches that can be on or off, like what you get in logic gates. But logic gates is not in paper 1. So binary is used because computers are made of switches that can be on or off. Okay. Let's try this one. Complete the table by writing the missing denary, 8-bit binary, or hex values. Hexadecimal, we got a 7. 8-bit binary, obviously they're all zeros. These are the ones we want to deal with. 8, 4, 2, 1. 4 plus 2 is 6. Plus 1 is 7. So what we do is we just bung in there the answer, which is 7. Bung that in there, bosh, done. Right, 49 in binary. Right. So the next bit we need to do is 0, 0, 128, 64, nope, right, 32. That goes in there. 16 is 48, so that's 48. Boom, 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 boom. Because you got 32 plus 16 is 48, plus 1 is 49. Bosh, done. Right. Brilliant. This one, nice and easy one. We got 66 in hex, and we got that. And we got that number here. So 32 plus 16, right, 64 and 32, sorry, 96. So we got 96 there. 96 plus 4, 100. Plus that, 102. So it's 102. So we're literally doing the placeholders, and I know the table off by heart, which is why I don't have to draw out the table. But if you feel like you got to draw the table, do it. Right, next one, 244. So the way we convert this to hex, it's given us that binary number. This is what I would do. You need to split that byte into 2 nibbles. So you got one nibble, 2 nibbles. So we know that's going to be 15, and 15 in hex is just going to be an F. And if you see 8421, it's just going to be F4. Bosh, done. And those are our answers. 4 marks in the bag. Bosh. Right, let's try another one. Tick one box to identify the largest file size. The largest file size is going to be 200 megabytes. In that one, 0.1 gigabytes, that's 100 megabytes. So it's going to be 200 megabytes. Tick two boxes to identify two file sizes that are equal to each other. So, 4,500,000 bytes, that's 4.5 megabytes. Simple as that. Right. Binary addition. A question they got to ask. So, what do we have here? So, following the rules, 1 and 0, it's a 1. 0 and 1, it's a 1. 0 and 1, it's a 1. Okay? Next one, 0, 0 and 1, it's a 1. Okay? So that is what we should have in our little nibble. 1 and 1 is going to be a 0. And then what we are going to do is just do a base. Right, I'd like to put them in here just to make sure. So here, we're going to have 0 carry the 1. Okay? And then the next bit, that's going to be 0 carry the 1. And then you have 0 carry the 1. Okay? And then here, we're just going to have another. Yeah, we're just going to have another 0 here, and we're just going to carry the 1 here. Okay? So that's literally what we got. So, our answer should be 0, 0, 0, 0, and all 4 ones. So, that is going to be it. Which is quite a strange one, but we've got 3 carries. Next one, we need to identify the binary shift that's been applied to the 8-bit binary number to get the following result. So what we've done here, that is a left, so we need to identify the shift, not do it. So it's a left shift because you've got all these 1s and the 0s. We're going left, so meaning those first 3, they're gone. So it's 1 mark for shift left, and we're shifting left by 3 places. That's 2 marks in the bags. Bosh! There you go. Okay? With this, because with the binary shift, you're getting rid of those 3. And you got the 1, and then you're just adding on the 0s in their place. You're just adding the 0s on. Okay? Nice and easy. Number 2. A student is performing a range of actions on the internet using their computer. You've got a range of protocols, rules basically. They're used for the transmission of data by the student's computer and the web servers that they are actually accessing. So what websites are accessing. So we're going to complete the table by identifying the most appropriate protocol for each of the tasks the student is performing. So requesting to view a news web page from a web server, that's going to be Hypertext Transfer Protocol. Or you could have Hypertext Transfer Protocol Security. Entering a username and password to access bank account, Hypertext Transfer Protocol Security. Downloading a text document from a web server, File Transfer Protocol. or you could have hypertext transfer protocol, or you could have hypertext transfer protocol security. Checking for new emails in your inbox, IMAP, or you could have POP. Okay, those are the protocols. So if I was doing this, for the first one, I'd have hypertext transfer protocol. Second one, I'd have hypertext transfer protocol security. Here, my immediate one, the one that goes boom, is file transfer protocol. And then here, I would have IMAP, instant messaging application protocol. Yep, if you get those, you're in for some marks, and you're going to be feeling pretty Sigma about it. Sigma meaning good, basically. Okay, some protocols have layers. Give 2 reasons why they have layers. That's because every layer in a protocol is independent of each other. So one layer can be changed without impacting all the other layers that go with it, whether it be the other layers above it or the other layers below it. So let's say you got transport layer. That's going to be independent of application and data link. They're not going to have any impact on each other. They're just doing their bit. They're just independent. They're just chilling out doing it. No interference from the others. And they and with layers, they can group together similar protocols. Okay, let's try another one. A student's computer is part of their home local area network. The LAN has wired connections. One characteristic is that they're set over a small geographical area. So another characteristic of a LAN is that it will be that all of the hardware is owned by the organization or by the person in the case of a home network. Okay, so there's no external hardware or external this, external that. All the stuff is owned by that person. All right, next one. Describe the benefits of a student changing their home LAN address to include wireless connections. So wireless connections is going to allow more devices to connect. So wireless devices would be mobile phones, tablets, iPads, etc. Saying those 2 things would get you 2 out of 4 marks already. And the benefits of a student changing their home LAN to have wireless: it's cheaper to purchase, and you can move wireless devices around. Hence, the word wireless. You can take it anywhere with you, and very easily too. Let's try the next one. State 2 drawbacks of changing their home LAN to wireless. Well, wireless is prone to interference, and you also get a limited range of signals. So with wireless, a Wi-Fi is strong at one point. As soon as you go up the stairs or into another room where the modem isn't, that signal's got to go through walls or floors, which is making the signal weaker. So for that, it's prone to interference, and it's limited range of signal as well. And the connection is actually less stable. So if I was doing this, I'd have less stable connection and limited range of signal. And some of us pretty much experience that every day. 3. Binary numbers can represent different forms of data. 1 is in the form of characters. So we got a complete description of how computers represent characters in binary using given list of terms. Not all terms are going to be used. Okay. Character sets. They're going to store all. They're going to store all of the characters that a computer can represent. Each character is going to be given a unique binary code. Lowercase and uppercase letters in a character set are given different binary codes. The reason why I'm saying different and unique, I could have said unique, but I think you're only allowed to use one word once, which is why I'm saying unique in one and different in the other. One example is ASCII. This character set uses 8 bits for each character. If the ASCII value for the character F is 70, then the ASCII value for the character L is going to be 76. That's 5 marks in the bag. So what words I've used? All, unique, different, 8, 76, bosh, done. Yes, let's go. So, binary numbers can also represent images. The table actually shows the colours that are used in an image and the binary value for each colour. So the metadata states that the image is 3 pixels wide and 4 pixels high. The data in the file starts on the top left of the image and goes from left to right, top to bottom. So we're going to state what is meant by metadata in an image file. Okay, metadata in an image file. So metadata is data about data. That's literally it. It's data about data. That's all you need to say. And examples of that is going to be... Okay. Nearly lost my train of thought there. So the binary data stored on the image is given. Whoa, we got a big one here. So we got to break this down. So the grid is given for the image. Each square is 1 pixel. We need to write the name of the colour in each square that the pixel will show for that image. Okay, so we've got to go back up on the table. So, 4 zeros, that's a red. So 4 zeros, red, red. So you got red and red. And then we got purple. That is our row. So if we're to go in here, so the first one's going to be a red, red, purple. Line 2, we're going to have blue. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so we're up to here. So we're going to stop here. That's our 12. Why am I doing that? You'll see now. You will see now. So that is a blue. That is going to be a green. And that is going to be a blue. So we know that's going to be a green. And then that's going to be a blue. So let's do that for 8, 12. Right, let's do that. 4, that's purple, 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 and bosh. So we got purple, purple, purple. Right, 4. We got 4 zeros, red. And then we've got green. And then we got my favourite colour, blue. And there we go. That's 2 marks just for doing something like that. So if I was doing a question like that, you can see that I've marked on every 12 bits to represent, right, that's a new line, let's go there. Okay? So line 1, mark it, mark off the border. Line 2, mark off the border. Line 3, mark off the border. Line 4, correct answer, Bosch. And how do I know that? Because we've got to look at, because the table is telling you. So this is literally telling you the answer. What you got to do is think, okay, let's split it up into 4s. Upstairs for thinking, downstairs for dancing. Otherwise, I'm just going to have to say yo fail. But I'm not going to do that because I want people to pass. Okay. A color depth of 4 is used, which means 4 bits are used to store the color for each pixel. So we need to state the maximum number of different colors that can be represented in 4 bits. And that's going to be 15. Because you're going from 0 to 15. Which in hex is actually 16. So 15, 0 to 15, which is actually 16. So maximum number is 16. Next one. Color depth is increased to 2 bytes. So we need to state 2 impacts that this change can have on the image. So the quality of the image can be improved. Yes, it will. But you're going to see an increase in file size. And if you increase a file size, and that's any file type, any type of file, more storage on your computer is going to be taken. On your computer, on your iPad, on your phone, it's going to be taken up. Okay, so if I was answering those questions, I'd say quality of image can be improved and the file size will increase. Right. The student has a text document and an image file that needs to be compressed separately. The student needs to reduce the file size of both these files as much as possible. So, we need to identify the most suitable type of compression for the text document. There's only 2 types, lossless and lossy. So let's say to do lossy, for instance. So we're basically saying, why would we choose lossy or lossless? But the correct answer is actually going to be lossless. Okay? Why? Because data will not be removed and data can be fully reconstructed. That is why you would use lossless. Okay? They will, if you were to say lossy, which is reverse, so why you would not have lossy? Lossy will remove data, and data cannot be fully reconstructed. So they will allow that if you did it in reverse for lossy. But they would like it if you had lossless. Okay? And then we need to identify the most suitable type of compression for the image file. Again, justifying our choice. So we want lossy because what it's going to do, it's going to reduce the file size more than lossless, and the image will only lose quality. Yeah, but the change may not be noticed. May not actually be noticed by the end user, meaning the person that uses the damn thing. And that is what I would have. Okay? 4A, security. So we need to tick one or more boxes on each row to identify all of the methods that can help prevent each threat. So we got spyware, brute force attack, data interception, SQL injection. Threats: anti-malware, pen testing, encryption, firewall. So, spyware, your best bet is going to be anti-malware. Brute force, just have a firewall. Data interception, have encryption. SQL injection, yeah, you're going to need some pen testing. Those are literally the answers. Okay? Now we're going to name and describe one threat to a computer system not given in question 4 part A. So we can't use any of these. So we have to use something else. So if I had to do a threat, that threat would actually be of a hacker. So they are the person who gains unauthorized access to a computer system or network to delete, manage, or access data. But their intentions are actually to steal it for their own self-based ends. But anyway, that is 3 marks straight in the bag. Bosh. Number 5. An artist has a computer that they use to create images. So, their computer uses hardware and software. The hardware has primary and secondary storage. So the question's asking, why does a computer need primary and secondary storage? Well, because primary storage is going to store data that the CPU has to access, and then secondary storage to store data in the long term. So I would say primary storage is needed to store data in the CPU that the CPU has to access, whereas secondary storage is needed to store data in the long term. That's exactly what I would be saying in that. Because secondary storage, if you turn a computer off, the data is still going to be there next time you log on. Whereas primary storage, that's going to be split into RAM and ROM, where RAM is volatile. You switch off a computer, gone. It's Ligma. Okay, we need to give one example of a secondary storage device that the artist's computer will have, an example of the data that will be stored on it. 1 mark for an example, secondary storage. Let's just say SSD, solid state drive. So what that will do. So example data, images created, can be 1. So other examples you're going to have hard drive, you have USB stick, flash memory card, a CD, DVD, even though CDs and DVDs are on their way out. And examples would be not just images created, it could be documents, it could be software, it could be files, it could be data moved to the RAM, from the RAM to the virtual memory. Speaking of which, next question. Computer has virtual memory. Table has 4 statements about virtual memory. Not all statements are correct, however, so we need to tick the true column for the statements that are correct, and rewrite any statement that's incorrect in the false column by changing the statement to make it true. Ooh, that's going to be a difficult one. Right, process elimination. Virtual memory is needed when RAM is nearly full. Right. That's true. So that's done. That's 1 mark. Section of memory is partitioned to act as virtual memory. No, it's not. So basically, a section of secondary storage is actually partitioned to act as virtual memory. That's 1. Second one, data from ROM is transferred into virtual memory. No. Data from RAM is transferred to virtual memory. Data from virtual memory is transferred back to secondary storage when needed. No. Data from the virtual memory is transferred back to the RAM when required. That's literally, that is 4 marks in the bag. Bosh. Bosh-tastic. Let's get to the next one. Computer has an operating system and utility software. So we got to state the need for utility software in a computer. Simple one. Performs housekeeping actions. Very simple one. Or, if you want to be pedantic, it's going to diagnose problems with a computer. So a lot of us will get notifications saying, oh, you might want to check this. Oh, this software may need this update or that update or that update. It's telling us the problems in which we may think about what to actually solve. So don't just think, just another bloody annoyance. If you actually look into it, they're not all annoyances. But hey, I digress. The artist uploads images to be displayed on a website. This is a client-server relationship. So we're going to identify the computer acting as a client in this scenario, justify our choice. So in this case, it's going to be the artist computer, and the justification for that is it's going to send the files for storage and send a request to the web server. So once we send so it's going to perform the user's actions, and it's also going to send the results to the web server. A request is sent there as well to store and upload the files, but it's not going to store data for others to access. And then it's going to get the artist is going to get a confirmation that the data has been uploaded for display. And then we need to identify the computer that's acting as a server in a scenario and justify the choice. So, server computer justification. That is going to be a web server. Why? Because the images are stored on the web server, which receives a request from the computer to upload them in the first place. And then what's going to happen after that is the web server is going to execute that request, where the processing and the handling of the request takes place. And then the web server is going to say, yep, uploaded, cushy, fine. So, web server, images are stored on the web server, and that will receive a request from the computer and upload them to upload them in the first place. That's the answer that I would have. Indeed. The artist is working with a programmer on the development of a new piece of software, which will allow users to edit images on devices like mobile telephones or mobile phones. They're considering releasing the software as open source instead of proprietary. So we need to describe two benefits to the artist and the programmer of releasing software as proprietary. Well, simple explanation. The programmer and artist can make a profit. That's going to be one. By selling for a fee. Yep, and also no one else can see the source code. That's the idea of proprietary. Users are not able to edit, and they're not able to edit the software, which means it cannot be copied and pasted at all. That is our 4 marks right there. Okay? Right, describe one benefit to the users releasing software as open source. It's free. It's free. Meaning, users don't have to pay. So it's freely accessible and users don't have to pay for it. And they can also view and edit the source code. They can copy and paste it to wherever they want, and they can fashion that code in a way they see fit. And now we're on to, let's just say the bloody 8 marker. Ooh. They always love putting questions like that. Yes, they put that in there every year. A shopping centre has a security system that has CCTV cameras to record activities in the centre. Security system has been upgraded to include facial recognition to identify, track movements of, and record individuals throughout the shopping centre. So we're going to discuss the positive and negative impacts of this upgrade, including ethical, legal, privacy. Okay. So it's out of 8 marks, and to get the 6 to 8 marks, the uno, the best of the best, we have to have a thorough knowledge and understanding of a wide range of considerations in relation to this question, and accurately present the material and make it detailed, and apply the knowledge and understanding directly and consistency to that context. The candidate has to weigh up both sides of the discussion and reference the impact of all areas, showing thorough recognition of influence and factors. So there has to be a well-developed line of reasoning that's clear and logically structured, and the information being relevant. So that's where we want to be. So I would say there are some ethical issues in relation to this upgrade of security in the shopping centre. Make it look like you're referring to the question. So ethical. So I've been mentioning ethical, privacy, legal. So ethical issues. Okay, so this is where we've got to give both sides. So users may feel safe because they know any actions are being monitored and action will be taken if needed. If users have not done anything, and there is no reason to be recorded or tracked, shall we say, so should not impact on them. So that's what we could say. Those who do have negative intentions are the ones who are likely to be tracked. and action taken if required. However, users feel unsafe because they feel like that they're being watched constantly, and their movements being tracked, which could be used for malicious purposes. Also, users may be unaware that they're being recorded, and so there needs to be informed consent. And users also do not know where the videos about them and their movements is stored, nor do they know how it is used. And then this is a key principle of the Data Protection Act 2018 and also GDPR. That's our ethics. And then I would also say there are some privacy issues in relation to the shopping centre security upgrade. So, privacy issues. So users may feel it's an invasion of their privacy. So that's going to be a big one. And then users are in a public place. However, users are in a public place and can be legally recorded by anyone anyway. Yeah, users feel like they may be being watched all the time, as we have already said, and users have not given their permission to be tracked, and users at the system may not know the system actually exists. So a lot of this actually links. So the privacy links with the ethical, but legal. So this is an important one. There are some legal issues. In relation to the shopping centre security upgrade. So, the Data Protection Act 2018 and GDPR need to be followed. Otherwise, the company will be fined up to 10% of their global turnover or a couple of million of British pounds, whichever is higher. That's what I would say there. So, GDPR and the Data Protection Act makes it a legal requirement for the shopping centre to inform users that their whereabouts are being recorded and the data is held for specific purposes and not kept any longer than is required. However, the centre is private property, so customers can choose not to actually enter the premises. So, the shopping centre can identify crime, people committing crimes like theft, which the shopping centre can use as evidence. So they can use evidence, basically, should they later rely on in court. Yep. So they can use that as evidence, thereby making sure the correct people are prosecuted. And that is a strong answer. That, I think, is a strong answer. Reason why? Because we made it logically structured. It's clear that we've mentioned that this is ethical, this is privacy, this is legal. Okay, so that's what we've done there. We've given both sides of the argument. We've referred it to the shopping centre. So that is what we need to be thinking about here. So we have to refer back to the scenario in which they have mentioned. Okay, so I'll leave us up a little bit, let you have a read. Okay, I think we're done. Right, last but not least. A car comes with many embedded systems. We need to identify, for example, like parking sensors. So we need to identify one embedded system that could be found in a car and explain why it's embedded. If I had to do an embedded system, I would say auto lights. One of the first things we see, especially at night. Why? Because it's got one function, which is to provide light in front of the car in foggy or dark conditions. It's limited, and I would say the auto lights will have one dedicated microprocessor that makes the lights work. That's exactly what I would say. Okay, so that's literally it. Others you could have, you're going to have auto brake. That's going to have one function. That's going to have one limited functions, and it's also going to be a dedicated microprocessor. Or you could have hard to change functions. So other characteristics, so you could have auto lights. Why auto lights? You could have sat nav. You could have cruise control. All of these, they're going to have a limited set of functions, and these functions will be hard to change. So if I was doing this, I'd be thinking, right, what's on a car? What's only on a car? I know, cruise control. Limited set of functions in which they're hard to change. That's 3 marks in the bag, and BOSH! Okay, hope you've enjoyed this video. Please remember to click that like and subscribe button and share this video far and wide. I have tried to make this as exciting as possible. Okay, and other than that, please remember to, like I said, please remember to click that like and subscribe button. Share this video far and wide. Write a comment down below in the comment section. And I will see you on the next video pretty soon. Thank you and bye for now. So please be sure to hit that like. And please also remember to hit that subscribe button. And another way to subscribe is to just click on this link, which is below each video I place. And if you like my content and you want to find out more about what I do, I've also got an online course called Introduction to Computer Systems on the Udemy website. So you just need to click on it. And there we go. So this is my online course, Introduction to Computer Systems. So this is the landing page for that course. So in it, you will learn. So these are some of the things we'll learn, like explaining the role of the central processing unit, describe the components of the CPU, provide an introduction to assembly language, which is low-level programming, explain the factors that affect the performance of the central processing unit, and I've also put in another bit that I'm interested in, the physics of overclocking the CPU, which may me develop an interest in electronics and also physics. So there's a lot more to it than even we realized. So this is the course content. So you've got computer systems, so I'm introducing you to it. Then I'm going into the different forms of architecture and assembly language. Then I'm going into the factors that affect it and the physics of overclocking the CPU. And then I'm going into logic, so combinational logic systems, makings of logic gates, sequential logic systems, semiconductors. Then I go into all things binary, where we introduce you to number systems, all the way down to doing binary and sound, images and text. And then finally we got input and output devices and the different forms of storage, so that's where memory will come in. And then my assessment is basically one big quiz of 30 questions. So you don't need any knowledge to do this course. All you need is a computer with a stable internet connection. So that's all you really need there. And why you should do the course? Well, wherever I don't know, I'll go out and learn it. So the way my brain is wired is I'm on the autism spectrum. So it will be an asset in helping you get through the online courses that we provide. So we understand how to explain things in simple terms due to my teaching background. So you could think of us as a real-life version of, say, a Sheldon Cooper from Big Bang Theory, minus the rudeness, or a C-3PO, but without the glitches. So I'm on the autism spectrum, so we're on the autism spectrum and have a rough idea on how to talk to them and relate to them. And my teaching style is that style I've crafted and one that works in a way that some people don't get if they only had tuition in the classroom or just want to study the subject a lot more. So this course provides you with the opportunity to go further than you would in the subject that you want to pursue. So those are some of the reasons why you should consider buying this online course, because once you buy it, it's yours for a lifetime. For some of my videos, I will go through programming tasks. So if you want to do these yourself, I have put a REPL link below on my programming videos. So you just click on REPL. And this is what you need if you haven't signed up at all. So you just click sign up. If you've got an account, you just click log in. And once you've logged in or signed up, this is the page that will appear. So if I was to log in right now, this is the page. So this will appear. So that will be the page there. And in addition to all that, I am also a private tutor where I offer my private tutoring services specializing in ICT and computer science. And I look forward for you coming to me for lessons. Goodbye for now.